in an if-then form. Then write the inverse, converse, and contrapositive. An even number greater than 2 is not prime. So we're going to write if an even number is greater than 2, it is not, then it is not prime. So we've got if an even number greater than 2, then it is not prime. Okay? So inverse is literally, see this right here? We are writing the word not. If it is not an even number greater than 2, then it is prime. See how we had a not in there and we took it out? We're either putting a not in or taking a not out. The converse, so we go back to the original. I know I'm saying this really fast, but I'm not going to move it from up here. I'm going to move it up, though. If it is not prime, then it is an even number greater than 2. So the converse is I switched it. If it is not prime, then it is an even number greater than 2. Finally, my contrapositive. If it is prime, then it is not a number greater than 2. Okay, let's talk about the next one. We've got an angle with a measure of 90 degrees is a right angle. Does anybody want to try to say out loud what the conditional statement would be? An angle with a measure of 90 degrees is a right angle. What's the conditional statement of that? So we got to put the if and then in there. So an angle with a measure of 90 degrees is a right angle. How would we write that for a conditional statement? Go ahead. That's perfect. So you guys heard what Quentin did? All he did is put if an angle has a measure of 90 degrees, then it is a right angle. That's it. Does anybody want to try the inverse? The inverse is where we put the not in there. Anybody want to try it? So if we've got if an angle has a measure of 90 degrees, then it is a right angle. How would we say the inverse? If an angle is not 90 degrees, then it is a right angle. Correct. If an angle does not have a measure of 90 degrees, then it is not a right angle. Who remember, okay, so inverse is when I make the whole not thing. Who remembers what converse is? It's when you do what? Switch the hypothesis and conclusion. Does anybody want to try the converse? So we've got the conditional statement. If an angle has a measure of 90 degrees and it is a right angle, what would the converse be? Anybody? Sam?
A right angle is an angle with a measure of 90 degrees.
If it is a right angle, then it is a measure of 90 degrees. Yeah. Okay. Now a contrapositive is just you're going to take that converse statement and put nots in it. So you're going to say if it is not a right angle, then the measure is not 90 degrees. Am I giving you guys too much to write at once?
Yeah.
Okay. All right, I will pause.
Very quick.
I will pause for a second. Okay. Conditional statement, you just have the if and the then. Inverse, if you make it negative. Okay? Converse is you switch it. Contrapositive is you make it negative and you switch it. That's how I remember it. Inverse, negative. Converse, switch it. Contrapositive, negative, switch it. Okay, we've got the if then. Can I go on, guys, or do you need another second?
No second.
Okay. For the third one, I'm going to give you the if-then statement, but then I want you guys to try. So if you got pencil, do it in pencil. If you got pen, write it on the side. I want you to try the inverse and the converse and the contrapositive of this one. And if you get done with C, go ahead and try D on the back too. So C says, if I dry the dishes, then you will wash them. I want you to try the inverse, the converse, and the contrapositive. If I dry the dishes, then you will wash them. Give me right lightly, and we can erase it if you need to. The inverse, the converse, and the contrapositive. And then D on the back, so if you're done with C on the front, D on the back, a square with a length of 3 meters has an area of 9 square meters. Give me the if-then, the inverse, the converse, and the contrapositive. Anybody want to try C? If I dry the dishes, then you will wash them. Anybody want to try the inverse? Go for it, Dana.
If I don't draw the dishes, then you won't have to wash them.
Yep. If I don't dry the dishes, then you don't have to wash them. Converse I've got up here. If you wash the dishes, then I will dry the dishes. And contrapositive, anybody? If you don't wash the dishes, then I won't dry them. Okay. Anybody want to tell me what the conditional statement would be for D? You want to try it? A square with a side of 3 meters has an area of 9 square meters. So I'm going to put what word first? Nobody knows, really. What word? If. If. And then I'm going to put a square with side length 3. If the square has a side length of 3, then what? It has an area of what? An area of 9. Somebody want to try the inverse? So I'm going to start with what? If a square does not have a length of 3, then its area is not 9. Converse, if the area is not 9, then, if its area is 9, then its length is finally, contrapositive. If its area is not 9, then its length is not 3. Okay, I'm going to move this up. And I'll move that square out of the way. Let's look at counterexamples. Okay. If x squared equals 36, then s equals 18 or negative 18, true or false? False. Because the square root of 36 is not 18, it's 6. If you visit the Statue of Liberty, then you've been to the state of New York. True or false? True. 2 lines intersect at most 1 point. True or false?
True.
True. Is that true? Can we have this? You have overlapping lines. This is false, and overlapping lines is my counterexample. If x is odd, then 3x is odd. So 1 times 3 is 3, still odd. Let's think of another odd. 3. 3 times 3 is 9, still odd. 5. 7. 7 times 3 is 21. Any? So I would say it was true. But 10 is not an odd. Okay. We're good. All right, now we're going to use some postulates to look at this diagram. Okay. Use the diagram to state the postulate that verifies the truth of the statement. We can refer to page 73. So let's look in our book. Page 73. Sorry, no postulates on that page. This must be an old one. Points E, F, H lie in a plane. So let's turn to page 926 in our book. Or your sticky note, if you put it in there like you're supposed to. Let's think. Which postulate refers to a line and a point make a plane? Which postulate? A line and a point. If a line and a point are there, it makes up a plane. If 2 points lie in a plane, then the oh no, that's not it. A plane contains at least 3 nonlinear collinear points. So that would be postulate 9. Points E and F lie in a line, labeled M. Which one is that one? A line contains at least 2 points, postulate 6. You guys awake today? Planes Q and R intersect in a line. Which one talks about 2 planes intersect at exactly a line? Two planes intersect, and their intersection is a line. Postulate 11. Okay. The points E and F lie in plane R, therefore the line M lies in plane R. Postulate 10. Yes.
If we're going on postulates, wouldn't number 6 be true then? Because number 7, if you have exactly 1 point.
You're right. All right, ladies and gentlemen, we are done with notes. So what should you have out in front of you? Handy dandy notebook.